Here we have a problem in algebra 2. That is, we have to solve the given rational equation for x. That is, we have to find the value of x. Okay, in my first step, what I'm going to do is I'm going to simplify the expression we have on the right side. That is, I'm going to add the fraction 60 over x squared negative 9 and 1. Okay, let me write the stuff on the left side as it is. That is 3x positive 1 over x negative 3. So here on the right side, I'm adding a fraction and an integer. Whenever I want to add or subtract a fraction and an integer, what I have to do is I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take this denominator x square negative 9 as a common denominator. So let me write 60 and this positive sign as it is. Now I'm going to multiply this integer 1 by this denominator x square negative 9. That is 1 times x square negative 9. Now, since I have multiplied this integer 1 by this denominator, now I can take this denominator x square negative 9 as a common denominator. Let me write it. Okay, now we have 3x positive 1 over x negative 3 equals to 60 positive. When I multiply this stuff by 1, so I'll be getting the same stuff, that is x square negative 9 over x square negative. This 9 can be written as 3 square. Okay, 3x positive 1 over x negative 3 equals to. Okay, here we can combine the like terms. That is, we can combine this 60 and negative 9. So let me write this x square as it is. When I combine this positive 60 and negative 9, I'm getting a positive 51. And the expression we have in denominator, that is x square negative 3 square, can be factored using the algebraic identity. That is a square negative b square equals to a positive b times a negative b. This is the difference of two squares. Whenever we have difference of two squares, it can be written in the factor form, that is a positive b times a negative b. So now let's consider the expression x square negative 3 square. This is exactly this form, a square negative b square. At the place of a, we have x, and at the place of b, we have 3. So when I write the difference of two squares, x square negative 3 square in factor form, so I'll be getting the same stuff. That is a positive b times a negative b. At the place of a, I have to write x. At the place of b, I have to write 3. So let me write this expression in factor form. That is a positive b, that means x positive 3 times a negative b, that is x negative 3. Okay, now what I'm going to do is I'm going to multiply both sides of this equation by this product, that is x positive 3 times x negative 3. When I multiply both sides of this equation by this product, I'll be able to get rid of the denominator on the left side and the denominator on the right side. So let me multiply both sides of this equation by x positive 3 times x negative 3. Let me write it on the left side also. I multiply by x positive 3 times x negative 3. Okay, so this x negative 3 will cancel, and here x positive 3 will cancel, and x negative 3 will cancel out. And now we have x positive 3 times 3x positive 1 on the left side. Let me write it. So x positive 3 times 3x positive 1. On the right side, we have x square positive 51. Okay, now let's multiply these two binomials using the FOIL method. That is, first we have to multiply the first terms. X times 3x is 3x square. Now I have to multiply the outer terms, x and positive 1. It's just 1x. And now I have to multiply the inner terms. Positive 3 times positive 3x will be positive 9x. Now I have to multiply the last terms. Positive 3 times positive 1 is positive 3 equals to x square positive 51. Okay, 3x square. When I combine this x and 9x, positive 9x, I'm getting positive 10x, positive 3 equals to x square positive 51. Okay, now let's write actually it's a quadratic equation in the variable x. Now let's write this quadratic equation standard form. Standard form means we have to get all the terms on the left side of the equation. On the right side, we must have 0. But here we have x square positive 1 on the right side. So to make the right side 0, I have to get for this positive x square and positive 51. For that, I have to subtract x square from both sides, and also I have to subtract 51 from both sides. Let me do it. So when I do so, this positive x square, negative x square will cancel. Positive 51, negative 51 will cancel out. When I combine 3x square, negative x square, I'm getting 2x square, positive 10x. When I combine positive 3, negative 51, I'm getting negative 48 equals to, on the right side, we have nothing, so I have to write 0. Okay, now when I look at the coefficient of x square, coefficient of x, and the constant term, everything is a multiple of 2. So we can divide each term of this equation by 2 to make the numbers smaller. So if the numbers become smaller, it will be easier for us to solve the equation. So let me divide each term of this equation by 2, including the 0 on the right side. This 2 will cancel out, and I'm getting x square. So when I divide this 10 by 2, I'm getting 5. That is, when I divide this 10x by 2, I'm getting positive 5x over here. When I divide this 48 by 2, I'm getting 24 equals to 0 over 2 is 0. Okay, now let's solve this equation. It's a quadratic equation. So I think this quadratic equation can be solved by factoring. So for that, we have to multiply the constant of negative 24 by the coefficient of x square. Actually, the coefficient of x square here is, we have to assume it's 1. When I multiply this 1, coefficient of x square 1, and the constant of negative 24, still I'm getting negative 24 only. So now I have to get two factors for this negative 24, so that the sum of the two factors equals to the coefficient of x positive 5. I think positive 8 and negative 3 will work. When I multiply positive 8 and negative 3, I'm getting negative 24. And also when I combine positive 8 and negative 3, I'm getting positive 5, which is the coefficient of x in this case. And now what I have to do is I have to divide both these factors by the coefficient of x square, that is 1. So even when I divide this positive 8 and negative 3 by 1, still I'm getting the same values, positive 8 and negative 3. Now to get the two values of x, what I have to do is I have to change the sign of these two factors. Okay, now let me consider the first factor over here, positive 8. If I change this sign positive, I'll be getting negative 8. That is the first value of x in this quadratic equation. And also if I change the sign of this factor, I'll be getting positive 3. So now I got two values, because since it's a quadratic equation, like the maximum number of solutions we can have for x is 2, and I got two real values for x when I solve this quadratic equation. One is negative 8 and positive 3. Whenever we solve rational equations, the solutions what we get, I mean the values we get for the variables, all the values we get for the variable cannot be considered as a valid solution. Always we have to check the values we get for x with the given equation. So if we take the first value of x, negative 8 for x, and we have to check whether there is there any chance for the denominator over here to become 0. Because if the denominator becomes 0, the value of the fraction will become undefined. So that particular value of x cannot be considered as a valid solution. So it's an extraneous solution, that is invalid solution. When I plug in x equals to negative 8 in this expression x negative 3, it becomes negative 8, negative 3, that is negative 11. Anyways, when x equals to negative 8, this denominator does not become 0. And also, let's check with this denominator. When I plug in x equals to negative 8 over here, it will become positive 64, negative 9. So this denominator also does not become 0. So when I plug in x equals to negative 8, the first value of x into the given equation, so both the denominators do not become 0. So we can consider the first solution, that is x equals to negative 8, as a valid solution. Okay, now let's verify the second solution, that is x equals to 3. If I plug in x equals to 3 into the first denominator, so 3 negative 3, it becomes 0. Since the denominator over here becomes 0 for x equals to 3, so the value of the fraction becomes undefined. So this x equals to 3 is an extraneous solution, that is an invalid solution. Okay, we have only one solution for the given rational equation, that is x equals to negative 8.